We have another PVA problem. Mr. Wazowski. I'm just kidding. Okay, what we got? A particle is traveling along the x-axis. Why is it an x-axis? I guess it's just linear motion, right? It's going back and forth. You know, it's going back and forth on this line. All right. Its velocity is given by this. Okay. What is the total distance the particle travels? Ooh, did you see it? Did you see the word? Okay. So if you're looking for total distance, you have to make the negative distances positive and then add them together.
Absolute value.
Yeah, so here you go. I think I know what this looks like. I mean, that's a quadratic, but let's just draw a quick quadratic really quick. Okay, so this is velocity. Velocity doesn't give you distance. What does it give you?
Velocity.
Yeah, velocity. Okay. So all the y values on my y-axis are velocity. They're velocity values. And so right here is your velocity positive or negative?
Positive.
What about right here?
Negative.
That is a negative velocity. Okay. What does that mean? What does a negative velocity mean? It's going backwards. Okay. Ooh, here's a trick question. Which velocity is faster? Which velocity is going faster? This positive one or this negative velocity? Yeah, the positive one's going slower.
It's because
Why is the negative one going faster?
because
It's farther from
it's farther from the x-axis.
the x-axis.
Yeah, come on. Tim.
Okay. So this one's more negative than this one is positive. This one's more negative than this one is positive. Like, let's say this one is like a 1, and this one down here is like a -3.
The question was.
No. We're not at the question yet. Okay, so I'm trying to make sure you guys know how to read a simple velocity graph. Okay, now when you guys started doing integrals, I think you learned that whenever you go like and find the area between the curve and the x-axis, that's gonna find what value will that be? Remember, the y values are velocity, right? Like meters per second. Okay, like that's a velocity. But what's the value, the number? Let's say I added all this up. There's clearly more negative than there is positive. So let's say I got a -5. I add all those areas up. Let's say this was a 1, this was a 1, and this one down here was a -7. And so I add them all up, I get a -5. What is that?
The area?
No, well,
Position.
that would be the position. Okay, so if this is the rate, the y values are the rate, the area between the rate curve and the x-axis, that's going to be amount. Okay, now -5, that's not the total distance traveled. That's known as displacement. And so what happened in my made-up scenario right here, the particle started somewhere. I don't know where it started, but it started here, and it went one space at the very beginning, and then it went back one. Oops, I skipped. 1, 2, 3, 4, 5, 6, 7. It went back 7, right? And this is where it's at, right here, at that many seconds, whatever that is. And then one more, a little bit of time passed, and how much farther did it move? It moved 1 right here, right? So now our particle finishes right here. And that is exactly 5 spaces away from where it started. Now, it's a -5, which means 5 spaces backwards to the left, okay? And if you were to count this, it would be 1, 2, 3, 4, 5. All right, you guys got that? That's known as displacement. You don't know that it went all the way back to -6 from where it started, okay? You only know -5. Well, what would be the total distance traveled? Not displacement.
9.
It would be 9, yeah. Because it traveled 1 here, it traveled 7 here, it traveled 1 here, which equals 9. Okay, last thing about displacement. Let's say this number is 11. Where is the particle at when we get to this value of t? We know the displacement. Where is it at?
6.
It would be at 6. That would be its current position. So this would be a 6 right there. So that make sense? That's called displacement. Now, if you take a rate function like this guy, and if I just do the integral of this rate function, I could put the t in here. I don't need it, but I can put it there. And I can go from A to B. So from whatever seconds this is, A to B, we know for my stupid little example there, we are going to get -5.
Okay.
Now, it only tells me the displacement, right? But what if we knew that we started at 11 and then the problem says, where's the particle now? Well, now you're going to have to add the displacement to 11 because that's where it started. And you guys told me what that was. Yeah, this is what? What's this? 6. It would be at 6. That would give you the position. If you want the position, you have to give your initial starting point, wherever you are at when it's A, and then you have to add it to the displacement. But this problem, sorry, back to this problem, it wants total distance. What you guys said for this one is, what? What are you laughing at?
Just the area under the curve.
Yeah. Okay, but you want the positive, right? You don't want a -7, you want the +7. So what do you have to do? You have to go from 0 to 3, and you want the absolute value of the velocity function. Now, here's where things get a little dicey. Now, oops, that's not right. Wow. Do you know how to calculus?
No.
Okay, so if I have a calculator, home free. Just put absolute values around this sucker in the calculator and go from 0 to 3, you're done. It's going to do all the work for you. But this one, I don't think it is a calculator one. So if it's not a calculator one, we have to know what this A and this B are to know when the area becomes negative. Okay, so all that to say, now I'm going to finally do the freaking problem. Okay, so let's graph this. Do you guys know what -b over 2a is? That's my axis of symmetry. So it's 6 over 2, which is 3. So my axis of symmetry is at 3. And then my vertex.
Where'd you get 6 from?
Oh, 6 was right here. It's a B.
Oh, okay.
Yeah. Now, if I wanted to find the vertex, I have to plug the 3 in. So let's do a little table over here. If I plug the 3 in, what do I get for my F? Let's see. We have 9 minus 18 plus 8. So what is that? 17. Okay, -1. Is that pretty good? Yeah. So I have 3, -1. Which actually, I don't even know if I needed the vertex, but I do need the intercepts. So let's solve that guy. Is that factorable? -2 and -4. So we have -2, or t minus 2, t minus 4. Is that pretty cool? Mm-hmm. All right. We had to find two numbers that multiplied to give me 8, but they added to give me -6. And it looks like +2 and 4. So +2 is right here, and +4 is right here. And then actually this right here would be your 2, and this right here would be your 4. Okay, so we know our function goes something like this. And we're going from 0 to 3. Oh, so 3 is right in the middle, huh? So 0, which would be all of this area, and then all of this area. So we know which how to split up this integral. We're going to go from 0 to 2, which is already positive, and we're going to add from 2 to 3 dt. Okay. Oh man, this is a lot of work. So t to the second power minus 6t. Maybe I shouldn't have done all that explaining at the beginning. Now this video is super long.
It's okay.
Is it okay?
Yeah.
I don't feel like it's okay.
It's okay. Thank you.
Is there an absolute value on the second
Oh.
function?
Yeah.
Oh, good call. Yeah, you want the absolute value there, or just throw a negative in front of it so that it becomes positive. Okay? Or you can switch the 2 and the 3. Okay, but I'm just going to do that. I'm going to put the negative in front of it. Okay, wow, running out of space here. Okay, what's the antiderivative of that? I don't know, but
It's
you're going to do it. So we get 1/3 t to the third minus 3t squared plus 8t. And we're going to plug in 2 and 0. And we're going to do the same thing.
Why do you make it 1/3 instead of just Preference.
Yeah, it's like I'm just used to. I don't like fractions very much, so yeah. Whenever cause like sometimes like there's numbers. I don't know. Yeah, you could divide by 3. It's fine. It's the same.
I was just wondering.
Stop. You're just hating on my math.
No,
Okay.
I'm not.
So 2 to the third power is 8. Yeah. 8 over 3, and then 2 to the second power is 4, so we get minus 12. 2 times 8 is 16. And then I'm going to subtract. I'm going to plug in 0, which just gives me 0. Everybody cool? Everybody's cool. All right, so 12 and 16, that would be positive 4. Positive 4 over 3 would be 12 over 3. And that's going to be a negative 3 over... Nah.
No.
I did something wrong.
It's positive.
It's a positive.
Yeah, because it's 16 and 12, so you have positive 4. So it's 8 over 3 plus.
Hold on. I lost myself. This. Oh, it's a positive 4. You're right.
Yeah.
So it's a positive 4, and then I make common denominators, which would be 12 over 3, which would be 20 over 3. Ew. I know how to write numbers. Okay, next one is... Okay, this is kind of cool because I'm going to plug in 2 later, and I already know what that's going to give me. All right, but if I plug in 3, that's going to be nasty. We have 27 over 3, right? And so it would be 9 minus. That would be 9 times... 3 squared is 9, and I have to multiply it times 3, which would be 27. You guys are making faces and stuff.
No, we're not.
3 times 8 is 24. Minus 20 over 3. Everybody's good?
Yeah.
You guys know how... Yeah? We're all good? Make sure my math is right. Okay, so 9 and 24 would be 33, right? 33 and negative 27 would be positive 6. We're subtracting 20 over 3. What's that going to be? Put this over 3. This would be 18. 18 minus...
Wait, what?
Don't we need to multiply by a negative?
Oh, wait a second. Because we shouldn't get a negative answer, right?
Yeah, we should.
Wait a minute.
Oh, yeah, we should get a negative answer. Then we're just going to...
Oh, yeah. Add the negative.
Oh, wait.
Yeah.
Right?
Yeah.
So, okay. So then do we get 2 over 3? It's, but we're making it positive. I don't see my answer anywhere. All right, so no, that's not the answer. Thank you, Tim. You have to add these 2 together. And remember, that's a positive right there. So we have 20 over 3 plus 2 over 3, which equals 22 over 3. And we're all happy. I'm happy. You happy?
Yeah.